Hello students! Welcome back to our online classroom. Once again, I am Ma'am Dea and I am your science teacher for today. This week, we will be discussing the kinetic molecular theory and two other gas laws that will relate the properties of gases that we have discussed last week. Kung hindi mo pa yan napapanood, ay pwede mong balikan ang video na yan gamit ang link na makikita nyo sa taas ng inyong screen. So let's start right away. What is the kinetic molecular theory? Bakit ba natin kailangang pag-aralan ang kinetic molecular theory? The kinetic molecular theory of gases helps us understand the different properties of gases at the molecular level. Because gases are invisible, it would be difficult for us to understand their nature. That's why we need the kinetic molecular theory para mas maintindihan natin kung bakit ganito ang behavior ng isang gas. The kinetic molecular theory has different assumptions or postulates. Now, what are these assumptions? The first assumption tells us that gases are composed of molecules. The distances from one molecule to another are far greater than the molecule's dimensions. Ibig sabihin, napakalayo dapat ang mga molecules ng gases sa isa't isa. Second, gas molecules are in constant random motion. They frequently collide with one another and the collisions in between them are perfectly elastic. Dito sa assumption na to, malalaman natin na yung mga molecules, pwede silang bumunggo sa bawat isa, pwede rin silang bumunggo sa walls ng kanilang container. Ngayon, balikan natin kung ano ba yung ibig sabihin ng isang perfectly elastic collision. When we say perfectly elastic collision, this is a type of collision wherein there is no loss of kinetic energy. Ang ginagamit dito usually na example ay yung billiard ball. Third, in kinetic molecular theory of gases, we will assume that attractive and repulsive forces are absent. Some gas particles may carry charges. Nalaman naman natin nung grade 8 na meron tayong dalawang klase ng charge. It can be positive or negative. Ngayon, kapag ang dalawang gas particles ay nagdadala ng magkaparehas na charge, there will be a repulsive force in between them. Maglalayo sila. Kapag naman ang charges nila ay magkaiba, yung isa ay positive, yung isa ay negative, sila naman ay magkakaroon ng attraction sa isa't isa. However, under the kinetic molecular theory, we will be assuming that the forces brought about by these charges are very weak, that they will be considered insignificant. And the fourth assumption, this was already discussed last week. So, the average kinetic energy of gas molecules is directly related to its temperature. The faster the movement of the molecules, the higher would be the temperature. Consequently, if the particles are moving slowly, it means that the temperature is low. So let's move on now to the two gas laws that we will be discussing today. The first of these two gas laws is what we call Avogadro's law. I have already introduced to you the scientist that you are seeing on your screen right now, and he is Amedeo Avogadro. Again, Avogadro's law is one of the gas laws and it relates two of the properties of gases that we have discussed last time. And what are those two properties? Avogadro's law relates the number of moles and volume of a gas. And according to Avogadro's law, they are directly related. So balikan natin, ano nga ba ibig sabihin ng directly related? When we say directly related, as one quantity increases, the other quantity also increases. As one quantity decreases, the other quantity also decreases. However, this only happens when both pressure and temperature are held constant. And mathematically, we can express Avogadro's law as V1 over N1 is equal to V2 over N2. Now, what do these variables stand for? V1 stands for initial volume, V2 stands for final volume, N1 refers to the initial amount of gas in moles, and N2 refers to the final amount of gas in moles as well. Again, the formula is written as V1 over N1, so that is the same as V1 divided by N1 is equal to V2 divided by N2. I hope you are holding your calculators right now so we can start our calculations. Let's try this problem. First problem, a 1.2 liter sample of gas is determined to contain 0.07 mole of nitrogen. At the same temperature and pressure, what amount would there be in a 20 liter sample? Again, tandaan po natin para malaman natin kung ano po ang given, pwede po nating tingnan ang units. Makikita po natin dito na we have here 1.2 liters and we have 20 liters. Since liter is a unit for volume, we can say that 1.2 liters can be our V1 and our V2 would be 20 liters. On the other hand, it is stated here that 1.2 liter sample of gas is determined to contain 0.07 mole of nitrogen. So mole is a unit for amount. That would be our N1. The question asks for what amount would there be in 20 liter sample. So 20 liters is V2, so N2 is missing. Okay, let's now solve this problem using Avogadro's law. So Avogadro's equation states that V1 over N1 is equal to V2 over N2. We simply substitute the values that we have written here. So V1 is 1.2 liters over N1, which is 0.07 mole. And that is equal to 20 liters over N2. Let's operate what we have on the left side. So 1.2 divided by 0.07 would be 17.14285714. Ngayon, bakit po natin sinulat lahat ng values? Kasi hindi pa po ito ang final answer. Pag tayo po ay nag-round off dito pa lang, magiging sobrang rounded off na po nung ating sagot. Is equal to 20 liters over N2. Lipat po tayo dito sa kabila. So, anong gagawin natin para N2 na lang ang matira? Ang gagawin natin, pagko-cross multiply natin ito. So, N2 is equal to 20 liters over 17.14285714. So, nakita niyo po yung ginawa natin. Pinagpalit natin ng pwesto si N2 at saka yung nasa kaliwa. And then, we operate that. 20 divided by 17.14285714. And we will be getting 1.17 moles. So, if we compare our values, makikita natin na tumaas si volume. So, expect po natin na tataas dapat si amount ng gas. And we have proven that in our answer. .6 moles of nitrogen gas occupies 3.80 liters at 25 degrees Celsius. What volume will it occupy at 73 moles? Now, here's the problem for most students. Iniisip kasi agad ng isang student na kung ano yung binigay na number sa kanya sa isang problem, lahat yun gagamitin. Pero hindi sa lahat ng pagkakataon ganun. Halimbawa dito sa problem na to, we know that this is a problem in Avogadro's law and you are given the temperature. So therefore, Huwag nyo nang pansinin yan kasi since Avogadro's law nga ito, ibig sabihin the temperature here would be constant. Okay, so let's write the given values. 47.6 moles of nitrogen gas, that would be your N1. And then it occupies 3.80 liters, that would be your V1. Okay, so paano nga ulit nalaman ni Ma'am Dea na si N1 ay 47.6 moles at si V1 ay 3.80 liters? I just looked at the units. What volume will it occupy? So, ang nawawala naman dito ay volume at 73 moles. So, using the same formula, V1 over N1 is equal to V2 over N2. We substitute the values that we have. So, 3.80, numbers na lang isusulat ko, over N1, 47.6 is equal to V2 over N2, which is 73. So, 3.80 divided by 47.6, dito po muna tayo. Medyo mahaba, 0.07983,193,277 is equal to V2 over 73. So, to remove the 73, we multiply both sides by 73. So, 73 times your answer on the left side of the equation, it would be 5.83 liters since it's volume. Okay, so tumaas si number of moles, tataas din dapat si volume. Kung halimbawa, nag-solve kayo, nakita ninyo, tumaas si number of moles, tapos si volume bumaba, and you know that it is Avogadro's law, it's a signal for you to recheck your solution. Kasi, lagi natin tandaan, for Avogadro's law, the volume of a gas is directly proportional to the amount of the gas. So, if your number of moles increases, the volume should increase. If the number of moles decreases, your volume should decrease as well. Okay, so let's go now to the next gas law. Our next gas law for today is the ideal gas law. And the scientist behind that is Benoit Paul Émile Clapeyron, who lived from 1799 to 1864. Now, what is the ideal gas law? The ideal gas law is a combination of all the laws that we have discussed in the past week and today. And those are, if you still remember, Boyle's law, and we have Charles' law. And for today, earlier, we had discussed Avogadro's law. So let's try to derive ideal gas law from what we have learned in these three gas laws. So Boyle's law relates pressure and volume. So ang sabi ni Boyle's law, volume is inversely proportional to pressure. Okay, so this is a proportionality sign. So it shows the proportionality in between variables. Charles' law states that volume is directly proportional to temperature. And kanina nga, diniscuss natin, Avogadro's law states that volume is directly proportional to the amount of substance, in this case, the amount of gas. Now, if we combine these three, we will be having V is directly proportional to N, directly proportional to T, and inversely proportional to P. Now, for us to convert this into an equation, since this is not an equation, kasi diba pag may equation, dapat may equality sign, we have to introduce a constant. And that constant would be R. So, V is equal to R N T over P, wherein R is your universal gas law constant. So, in a short while, I will be showing you the value of R. And then, we can rewrite this so that it would become a single line equation by multiplying both sides by P. And we will be having PV is equal to RNT, or better, PV is equal to nRT. And this is your ideal gas equation. So what is the ideal gas equation or the ideal gas law? The ideal gas law was based on experimental measurements of the properties of gases. Here we can see all the four properties that we have discussed in lesson number 1. We have pressure, we have volume, we have amount of substance, and we have the temperature. So ano ba yung dapat natin tandaan kapag tayo ay nagsosolve ng problems involving ideal gas law? Kung nung nakaraang mga discussion, okay lang na gumamit tayo ng iba-ibang unit except dun sa temperature, 'di ba? Kasi sa Charles law, in-specify ko naman sa inyo na yung temperature ay in Kelvin dapat. This time in ideal gas law, we will be strict with the units. Pressure must be in atmospheres. Volume must be in liters. N must be in moles. T must be in Kelvin. And R is your universal gas constant equal to 0.0821 liter atmosphere mole Kelvin. Okay, so dahil constant siya, yan ay lagi nyong gagamitin at walang case na ako ay maghahanap ng value ng R kasi ang R ay isang constant. So another way for you to remember the units for P, V, N, and T is to look at the unit of the universal gas constant. If you will notice, it is 0.0821 liter atmosphere mole Kelvin. Here you can see the units that I have stated a while ago. We have liters, atmospheres, mole, and Kelvin. So let's go now to the sample problems. So first problem, 6.5 liters of an ideal gas is contained at 2.9 atmospheres and 27 degrees Celsius. How many moles of this gas are present? So it is very obvious here that we are looking for N because we are asked for how many moles. Well, let's write the given values first. We have 6.5 liters, that is your volume. Then we have pressure of 2.9 atmospheres. Then we have temperature of 27 degrees Celsius. However, again, remember that the temperature must be in Kelvin. So you have to add 273.15 to convert this to Kelvin. I hope you can still remember this conversion factor. So, 27 plus 273.15 is 300.15 Kelvin. And then, of course, R is 0.0821 liter atmosphere mole Kelvin. And then, again, we are looking for N. So, let's try to substitute these values to our equation. PV is equal to nRT. P is 2.9 atmospheres. V is 6.5 liters. Is equal to N, which is missing. R is 0.0821 liter atmosphere mole Kelvin. And your temperature is 300.15 Kelvin. So, imumultiply po natin yung nasa kaliwa, imumultiply din natin yung nasa kanan. So, hindi ko na isusulat yung unit dito sa solution natin para hindi na siya mag-take ng maraming space. So, 2.9 times 6.5 is 18.85. And then, on the right side, we have N 0.0821 times 300.15. We will be getting 24.642315. And then, para matira si N, kasi si N ay nawawala, we divide both sides by 24.642315. We do the same for the left side. Okay, so what will we have now? 18.85 divided by 24.642315 is 0.7649. So we can round that off to N is equal to 0.76 mole. Okay, so let's go to our second problem. At what temperature will 0.654 moles of neon gas occupy 15.2 liters at 1.95 atmospheres? So, ang tanong dito, at what temperature? So, ang nawawala ay temperature. Let's write the given. N is equal to 0.654 moles. The volume is 15.2 liters. Pressure is 1.95 atmospheres. And your constant is 0.0821 liter atmosphere mole Kelvin. Ideal gas equation is PV is equal to nRT. Let's substitute the values. So, P is 1.95 atmosphere. V is 15.2 liters. N is 0.654 mole. And then R is 0.0821 liter atmosphere mole Kelvin. And the temperature is missing, so we write T here. And then we operate the left side and the right side. 1.95 times 15.2 is 29.64. And then 0.654 times 0.0821 is 0.0536934 T. So, kailangan si T lang ang matira. So, we divide both sides by 0.05 36934. And we should get 552. The unit for temperature must be Kelvin. So, our final answer would be 552 Kelvin. Okay, so always remember na kapag ang ginamit niyong mga unit ay yung ating prescribed units, ang unit ng lalabas sa sagot ay yung prescribed unit din. Ngayon, kapag may pagkakataon naman na binigyan kayo ng value na hindi prescribe ang unit, kailangan mo na siyang i-convert katulad po ng ginawa natin kanina sa first problem kung saan kinonvert pa natin si 27 degrees Celsius sa Kelvin. Okay, so that's all for today. I hope I have helped you understand the two gas laws as well as kinetic molecular theory. If you have questions, don't hesitate to comment them down below in the comment section. And don't forget to like and subscribe if you are new to this channel. So, see you in my next video lesson. Bye!